Today's lesson is going to be a continuation of graphing those polar functions. And so to remind you, the AP Pre-Cal exam is not going to have you actually sketch one by hand, so you won't have to graph one. It will only appear in the MCQ questions on the AP exam. But you're expected to understand those polar functions and understand all of their parts as well for the graphs and its domain restrictions and its attributes. So when working with the multiple choice questions involving polar functions, it is advantageous to evaluate the function at several values of theta. Utilizing the multiple choice options can be helpful when determining which values of theta to consider. You may also want to consider graphing it in the rectangular because that sometimes helps as well. So we went through a series of different polar equations and talked about their different attributes last time. So now we're going to look at some of these MCQs that you can see on the test so that you're able to answer them. On this example here, it says the figure shows the graph of the polar function r equals f of theta for 0 to 2 pi, where theta is 0 to 2 pi, in the polar coordinate system. Which of the following could be an expression for f of theta? So this is one that's asking for the equations. And so last class we talked about looking at some specific parts. For example, we said that the cosine is always on the polar axis. And so we have no petals on the polar axis, so I can quickly eliminate my cosine ones. Where the sine of theta would never be on this polar axis. So we know this one is sine of theta here. One of the things that you might want to do is eliminate some of the values. For example, here I see at 0, it is at 0. So we know that f of 0 equals 0. When I plug in 0 for theta here, that gives me the sine of 0, which we know is 0, times that -3 would give me 0, which is at the pole. So that works. Where if we plugged in 0 here, the cosine of 0 is 1. 1 times 3 is 3. And so we would have a value right here on the polar axis. So that's what we're talking about there. I see that we have a point here. And so that could be a pi over 2 with a negative over here, or it could be 3 pi over 2. So we would want to try one of those. So I'm going to plug in pi over 2 here. If I plug in pi over 2 in this one, that would give me 3 pi over 2. And I know the sine of 3 pi over 2 is -1 times -3 would give me a +3. And so there is our point. Let's try that. So -3 times sine of 3 times pi over 2. And so we get sine of 3 pi over 2 times -3. All right, so the sine of 3 pi over 2 is -1 times -3 gives me a +3. So pi over 2 is this one right here. I get a +3. That would be this point right here, which is clearly not on the graph. And so I can eliminate this one. I'll go ahead and show you this one just so you can see it works. We get 3 of sine of 3. I'm going to plug in 3 pi over 2. That gives us the sine of 9 pi over 2. You can't see that, sorry. There it goes. So 2 goes into 9 4 times, and then we have a half a pi left. And so 1 pi, 2 pi, 3 pi, and 4 pi, and then half of a pi. And so we know that is pi over 2, basically. It's coterminal with that. And so our sine value there would be 1, and 1 times 3 is 3. So what we plugged in there was 3 pi over 2. So 3 pi over 2 is at 3, which is that point right there. So A would be our answer. Now we talked about a couple things to look at when you were looking at these. That's positive, and so sorry, that is sine, and it is odd, so that tells us it's 3 petals, so that would not help us eliminate because all of these had 3 petals, but we were able to eliminate these two by knowing that it is not on the polar axis. All right. For our next example here, we have the limacon or limison with the loop here. And so in that case, we know that we are looking at one that has a midline. So we've got that plus or minus value on there. Again, this is vertical. And so I know that I can cross out my cosines. Cosines are eliminated immediately. When we are horizontal, that's when we want those cosine values. We should know that this is opening downward, so it's going to be a negative right here. So that is an option in you looking for that. We see here that at 0, it is 2, so we know f of 0 equals 2. So we can also look at our values here to figure out which one that would work. If I plugged in 0 here, the sign of 0 is 0. So 2 minus 0, that is the correct answer. If I plugged in 0 for this one, the sign of 0 is 0. So this goes away. And we also get 2 there. So that one didn't help us as much. We can plug in some more points, but again, this negative tells me it is going down. If it was the positive one, we would have the lemicon up here. All right. Let's get some questions where you actually have to know a lot more about this graph here. It says a portion of the graph of the polar function r equals f of theta, where f of theta equals -3 sine theta, is shown in the polar coordinate system for A, where theta is A from to B. If 0 is less than or equal to A, which is less than B, is less than 2 pi, which of the following could be the values for A and B? So we're looking for an interval here for our domain restriction, basically, because that theta is the independent one. And they're both between 0 and 2 pi. And so we want to look at this graph and we want to see where it's restricted. This is one where I would definitely graph this on the rectangular so that I can see what's happening onto this graph. So here I'm going to graph my rectangular. There is no midline with this. It's 0 since there's not an added value. So my midline would be right here on the x-axis. The amplitude is 3. So I would go up 3 and down 3. So there's my bottom line and there's my top line for this sine curve. Now the sine curve starts on the midline, so I'm going to start right there. It is negative, so instead of going up and down, it's going to go down and up. Oops. There we go. All right, we know this is at 2 pi, this is at 1 pi, and this is at 0. And then we've got pi over 2 here, and we have 3 pi over 2. Get comfortable breaking it down to those important parts where our minimums and our maximums are, because it's easier to think through. All right. As we go through these values here, we see that from 0 to pi over 2 right here, these are all negative. Well, let's think about that. On my polar axis, from 0 to pi over 2 are these right here. And if they would negative, they would reflect down to the third quadrant. So let me write that down here. I know from 0 to pi over 2, my values are negative. So it reflects to quadrant 3, where we do not have the points. So we know from 0 to pi over 2 is out of the question. It can't be that one. All right. For our next values here, from pi over 2 to pi, they are also negative. And so if we think about our pi over 2 to pi right here, they are negative, and so they would reflect and they would be right here in this quadrant. So now we know it is that part right there. I will show you a little bit more just to continue with that. In this case, from 0 to pi wouldn't work because we did have the negative values here and the negative, but then that would be a part here and a part here, so that doesn't work. For our last one, we had a pi to 2 pi, and so that's all of these values down here. In this case, it's all of these. Again, they're all positive, so I should have some values over here. All right. Your other option is to make a table of values, and so we can make a table of values with some of the ones that we have here. Thinking through this equation right here, obviously we start with 0. That's the easiest one. When I plug in 0 here, the sign of 0 is 0 times anything gives us the point 0. So we've got that point at the pole right there. Then I just get a few more points just to check. So pi over 4, the sine of pi over 4 is root 2 over 2. And so we get this right here. Well, pi over 4 is right here. That value is negative, so I don't even need the decimal approximation. I know it's here, which does not land on our graph. And then I would keep going with that. The next one, pi over 2. Sine of pi over 2 is 1 times negative 3 gives us negative 3. So pi over 2, negative 3, that starts to work right there. And so that's another way to help us find the answer. So you got a couple different options. Graph that rectangular, see what's going on that way. Graph some points, see if it's happening in that way. All right, so let's look at another one right here, same type. If you want to go ahead and pause and check your answer when you're finished. This question is worded basically exactly the same as the other one. We are just now looking for this portion. So the equation that gave us 3 cosine 3 theta. As soon as I see this has that n value, I know this is a rose shape graph. So I have to think this is a portion of my petal. So keep that in mind as well as you're going through there. I'm going to graph my rectangular one. Again, we don't have a midline here. Well, it's at 0, better said. The midline stays at the x-axis since we have no vertical translation. Our amplitude is 3, so I'm going to go up 3 from that midline, down 3. This is cosine, so cosine starts at the top and then goes back to the top, so we've got something like this. Now on this one right here, we do have to think about this. On the rectangular, remember we said that is a horizontal dilation, and so it changes the period of the graph. So the regular period for cosine is 2 pi. I'm going to divide that by 3. So this has a period of 2 pi over 3. Hopefully you're good at your fractions there because you are going to need that skill. So halfway between these two would be pi over 3. So that's where we are down here. Halfway between 0 and pi over 3, that's when we would be at the midline. And so that's pi over 6. That's what you get when you divide pi over 3 by 2. Pi over 3 plus pi over 6 is going to give us pi over 2. So now we have our 4 main points right there. We are looking for these points right here. So the first ones and most obvious ones to start would be our first section right here. We have 0 to pi over 6. It is positive right there. And so our angles 0 to pi over 6 are the ones right here, and it is positive, so that would give us that shape. And so that is going to be our answer. That was easy. So let me show you the other one so you can see how it's not correct. Right here, for example, 0 to pi over 2. We are looking for all of these points right here from 0 to pi over 2. And so we've got positive ones, we've got negative ones. And so if we look from 0 to pi over 2, we're looking at all of these here. It gave us some positive ones, which would be these, but then it would also give us some negative ones, so we would need some values over here that we do not have. Same thing with the 0 to pi over 3. We've got positive ones and negative ones. And so we would also need some points on this side here. All right, for our last one today, on this example here, it tells us a figure shows the graph of the polar function r equals f of theta, where f of theta equals 6 cosine 3 theta. In the polar coordinate system for 0 to 2 pi, there are 4 points labeled A, B, C, and D. So we've got our petals labeled at A, B, C, and the pole right here is labeled at D. If the domain of F is restricted to pi over 3 to 2 pi over 3, the portion of the given graph that remains consists of 2 pieces. One of those pieces is the portion of the graph in quadrant 3 from C to D. Which of the following describes the other remaining piece? This is definitely one that I would want to graph the rectangular one for. It makes it a lot easier to see. And so we've got 6 cosine 3 theta. So my amplitude is 6. So I'm going to go up 6 and down 6. It is cosine, so it's going to start at the top, go back up to the top. Luckily, we have the same ones that we just used. So this is 2 pi over 3. This down here is pi over 3. And then we got pi over 2 and pi over 6 right here. All right, so the piece that they are asking for is pi over 3 to 2 pi over 3. So we're talking about this whole section right here. We do have a piece where it is negative and we have a piece that is positive. So we need to keep that in mind as we go through this. So we'll start first from this part. Pi over 3 to pi over 2 is negative. So pi over 3 is right here. Pi over 2 is right here. So these are negative. Well, we know that when it's negative, instead of going towards the angle, it goes in the opposite direction. So if this right here is a negative and we reflect it, then we're talking about these values right here. And so those are the values that they said from C to D. C to D are the ones that we're looking at here. The next part that we're looking at is from pi over 2 to 2 pi over 3. So pi over 2 is right here. 2 pi over 3 are these values right here. In this case, these values are positive. Well, values that are positive come in the same direction from the point. And so we're talking about these right here, which are from D to A, which is our C. So this takes a lot of thought. You have to think through on what is happening on the graph here, how polar coordinates work. You need to remember that you find the angle first. If it's positive, you need to move out. If it is negative, you move in the opposite direction, and you need to put that all together in order to answer these questions. All right, that's our day 2 of polars.